Hey guys, how are you? We're going to continue with our lessons on the expanding universe idea, the Big Bang Theory, galaxies, and so forth. The last time you watched a video, it was about basically the first bit of evidence that suggested the universe is expanding, the Doppler redshift that Edwin Hubble recognized, and we usually in class we talked about how that connects to sound. So here's going to be a piece on the second part, the cosmic microwave background radiation. This is actually a really, really cool story. Arnold Penzias and Robert Wilson found some cool stuff. So I'm going to show you a couple of video clips about that. The really thing, what you need to know is that there is leftover radiation from the event of the Big Bang, and that's the cosmic microwave background radiation. Initially, it was probably visible light, but because it's been spreading out for 14 billion years or so, and it's been moving away for 14 billion years, now it's no longer in the visible light part of the spectrum. It's now stretched out so much it's microwave background radiation. Billions of years from now, there might be radio wave background radiation, but we'll see. So we're going to try this. Here we go. All right. Is this loading? I hope you can see this.
My name is Mordecai Mark Maclow, and my position is Curator of Astrophysics. So Big Bang Theory suggests that the universe was once hotter than the surface of the sun. Well, if there's one thing we know about the surface of the sun, it's that it emits light. What Big Bang Theory is claiming is that the entire universe was once that bright. If so, where is all that light? Well, it turns out that it's right here, pervading the universe. But because the universe was expanding, the light got stretched to longer and longer and longer wavelengths. And although it was emitted, rather coincidentally, as visible light, it got stretched from visible yellow light to infrared to microwaves, radio waves. And those radio waves pervading the universe can be detected with a microwave antenna. Heck, they can be detected with a TV antenna. An old-style on-the-air TV, a few percent of the noise that you get when you tune to an empty channel was from the early universe. Those radio waves are what we call the cosmic microwave background. So the background of microwaves that pervades the universe, because they were emitted during the early expansion of the universe and have been traveling and getting stretched out ever since. The idea that there ought to be background radiation was actually first understood in the 1940s, with the idea that there must be a hot, dense beginning to the universe. But sad to say, that prediction was more or less ignored for many years. And it wasn't until the 60s that Peebles and Dickey at Princeton University said, we ought to try and check this prediction, and set out to do so. Well, by the 60s, technology had advanced, the space race had started. People were building microwave antennae not to look for some crazy idea of some physicist sitting in a lab somewhere, but to follow communication satellites. And a couple of electrical engineers by the name of Penzias and Wilson got a hold of one of these antennae that had been used to follow the Echo communication satellite and thought to themselves, we could do astronomy with this. And so they started using it to try to detect emission from gas in the Milky Way galaxy. Now, they were rather good engineers. And so the first thing they did was point their antenna at an empty patch of sky so they would be able to measure its noise level. And darn it all, there's something wrong in the system. They had too much noise. That is, their antenna was detecting a signal which they interpreted as noise, that was more than they expected. So they started debugging their circuit and checking all the connections. And at one point, they even suspected pigeon poop in the antenna of emitting enough microwaves to throw off their sensitive detectors. So they chased all the pigeons out and cleaned it off. And they still had this noise when they pointed at an empty patch of sky. They finally convinced themselves that they had detected cosmic radiation. So they went to a conference and said, guys, there seems to be some sort of cosmic radiation pervading every direction we look. And some physicists said, that's interesting. You ought to go talk to Peebles and Dickey down the road at Princeton. So they did. And Dickey turns to his lab and says, boys, we've been scooped. Because the very thing that they were looking for, the echo of the Big Bang, the baby picture of the universe, had been discovered by these communications engineers 20 miles down the road. Peebles and Dickey and Penzias and Wilson published papers back to back, a theoretical paper saying this is what we predict, and the observational paper saying this is what we saw, but only the observers got the Nobel Prize.
All right, so from that clip, and I would really like you guys to watch 5 minutes of this clip, only from about the 26th minute to the 31st minute, 4.5 minutes or so. Another version of the story about Penzias and Wilson. You should be able to answer question number 11 on the note sheet. How does cosmic microwave background radiation contribute to the Big Bang Theory? And the bottom line is, it's sort of the echo of the Big Bang. All right. From here, we'll go into stars. Adios.